In this video, we determine how to find the surface area of a curve of revolution in calc. If I'm looking at a cylinder, to find my surface area, if I'm just talking about putting something around the actual outside edge, not covering the two ends, I need to know this whole distance around, which is, when I flatten it out, just this rectangle. Well, the edge of this rectangle is equal to the circumference of the circle, so that would be 2 pi times my radius, 2 pi r is radius, times whatever the length of that amount of the curve is. So we can use that same idea to find the surface area of an irregular shape. So if I just look at this little piece, I can find what it's, that looking at just that circle, I know just that circle, its circumference is 2 pi r, but then I have it for the entire length of the curve, so I need to multiply by the length of my whole curve. So in terms of calculus, my radius here is the function in terms of x times my arc length. So we have that formula for arc length here, which is the square root of 1 plus the derivative squared dx. And we're integrating from a to b. So we want to find the surface area formed by rotating y equals 2 radical x from 1 to 3 about the x-axis. So I like to start with a little sketch, just a sketch, not exact. So there's a rough sketch of y equals 2 to the x. We're only looking from 1 to 3, and I'm rotating around the x-axis. So my shape is going to come down here and look kind of like this. So for these, we need to know what's our radius. So the radius of each of these kind of washer types of things we're doing, that's my radius. My radius is just equal to the curve, which is 2 radical x. But then I also need to figure out my arc length, right? I also need to know how many of those I need to be putting together. So to get my arc length, the first thing I need to do is take my derivative of the curve, so that's just going to be 2 times 1/2 x to the negative 1/2, so that's just x to the negative 1/2. Then I need to take that derivative and square it, and I will get x to the negative first, or 1 over x. And I like to do as much of my work kind of off to the side before I go to my formula first. So for arc length, I know I need to do 1 plus that derivative squared. So that would give me 1 plus 1 over x, which would be x plus 1 over x. So now I'm ready to go to my surface area formula. So surface area is the integral from 1 to 3 of 2 pi times my radius, which is 2 radical x, times my arc length. So arc length is the square root of x plus 1 over x dx. And I'm going to clean this up a little bit. So I'm going to pull out the 4 pi. So I have 4 pi, the integral from 1 to 3, the square root of x times, and this square root, when I have a fraction, I can break it up. Square root of x plus 1 over square root of x dx. So these radical x's simplify out. So I have 4 pi, the integral from 1 to 3, the square root of x plus 1 dx. Now I tend to use a u substitution here, so I say u equals x plus 1, so du is just x. So I'm really going to integrate this and just change my bounds. So I have 4 pi, the integral, 1 plus 1 is 2, 3 plus 1 is 4, so from 2 to 4 of u to the 1/2 du. So I have 4 pi, integral of u to the 1/2 is going to be 2/3 u to the 3/2, evaluated from 2 to 4. So this becomes 8 pi over 3, 4 to the 3/2, so 4 cubed is 64, the square root of 64 is 8, minus 2 cubed is 8, the square root of 8 is 2 radical 2. And we could get a decimal approximation, but this is as exact an answer as we can work with. So 8 pi over 3 times 8 minus 2 radical 2. We can also find surface area even if we're rotating around the y-axis instead of the x-axis. So here we have the line y equals 4x plus 1. So again, rough sketch. We're going from the point 1, 3 to the point 4, 15. So here's that piece of the line I'm rotating, but I'm rotating around the y-axis. So it's coming over here. So I'm looking for the surface area for this rotation, this curve. So my radius goes out to here, but it needs to be in terms of x equals instead of y equals, because everything is relation to the y-axis this time. So x is going to equal y plus 1 divided by 4. So that's going to be my radius. Next, I need to figure out my arc length. So the arc length is the length of that curve, so I need to look at my x and find x prime. So x prime is just 1/4 times that y plus 1, that's that's x. So then x is just 1/4 for my derivative, and then I have to take my derivative and square it, and I get 1/16. So then before I go to my formula, I know I need to do 1 plus my derivative squared, which would be 1 plus 1/16, which is 17/16. So now I'm ready to go into my surface area formula. So surface area is equal to the integral. I'm doing this in terms of y, so my y value here is 3, going up to a y value of 15. 2 pi, my radius here is 1/4 y plus 1. Times the square root of the 17/16, and then dy. Okay, so lots of cleaning up to do. So 2 pi times 1/4 is just pi over 2, so I can pull that out front. So I have pi over 2, the integral from 3 to 15 of y plus 1 times, and this is actually a constant, square root of 17 over 4 dy. So I can pull that out front as well. So I have pi times the square root of 17 over 8, the integral from 3 to 15 of y plus 1 dy. So now I have pi square root of 17 over 8, and when I take my integral, this is 1/2 y squared plus 1, evaluated from 3 to 15. So I have pi times the square root of 17 over 8, times 15 squared is 225, so 225 over 2 plus 1 minus 3 squared is 9, so minus 9/2 plus 1. And evaluating out and cleaning this up, this works out to 27 pi, missed my 27 pi, square root of 17 all over 16. That's a little hard to read. Let me rewrite it up here. 27 pi, the square root of 17, all over 16.